In this exercise, we are going to find the volume of the solid of revolution that we get by rotating around the x-axis the region R that is enclosed as shown on the graph by the curves f of x equals 1 plus sine 2x and g of x equals 1 plus cosine 2x. The graphic on the right shows how we obtain the solid of revolution by rotating the region R about the x-axis. We revolve the solid of revolution around the y-axis to get different perspectives of the solid. We can see from this angle that there is a hollow or cavity on the backside of the solid of revolution. That is because the lower boundary of the region R is not the x-axis. The lower boundary is a portion of the graph of g of x equals 1 plus cosine 2x. There is also a smaller cavity on the other side of the solid of revolution. Since g, and not the x-axis, forms the lower boundary of R, and since g is non-negative, we use the washer method to determine the volume of the solid of revolution. According to the washer method, the volume of the solid of revolution is equal to pi times the integral from a to b of the square of f of x minus the square of g of x. We are assuming, of course, that f of x is at least as big as g of x on the interval from x equals a to x equals b. We just have to determine the interval of integration. The values of a and b are the two smallest positive values of x where the graphs of f and g intersect. And so we equate the y values of the two functions. We set 1 plus sine 2x equal to 1 plus cosine 2x. And so we are looking for angles to x whose sine and cosine values are equal. The smallest positive angle whose sine equals its cosine is pi over 4. And so the lower limit of integration is pi over 8. The next positive angle whose sine equals its cosine will be in the third quadrant, where both sine and cosine are negative. This time 2x equals 5 pi over 4. Therefore x equals 5 pi over 8. And so it's time to set up the volume integral. The volume of the solid of revolution should be equal to pi times the integral from pi over 8 to 5 pi over 8 of the square of 1 plus sine 2x minus the square of 1 plus cosine 2x. We leave it as an exercise for the viewer to check that the integrand multiplies out to 2 times sine 2x minus 2 cosine 2x plus sine squared 2x minus cosine squared 2x. Using a double-angle trigonometric identity, sine squared 2x minus cosine squared 2x equals minus cosine 4x. An antiderivative of 2 sine 2x is minus cosine 2x. An antiderivative of minus 2 cosine 2x is minus sine 2x. And an antiderivative of minus cosine 4x is minus 1/4 sine 4x. All of this we evaluate from pi over 8 to 5 pi over 8. Plugging in the limits of integration into the antiderivative, the viewer can easily check that the volume of the solid of revolution is 2 times the square root of 2.